Okay, fundamental trig identities. I'm going to try so hard to make this short, but it might not work. Okay, so a trig identity is an equation involving trig functions that is true for all values for which every expression is in the equation is defined. And identities help us to evaluate functions, simplify expressions, prove identities, and solve equations. So here are the fundamental identities. There's the quotient identity. So that's tangent of theta equals sine over cosine. And then cotangent is cosine over sine. You should know that one already. Sine is the same thing as 1 over cosecant because sine is the reciprocal of cosecant, which means cosecant is the same thing as 1 over sine. Same thing for cosine and secant, and for tangent and cotangent. Okay, then the Pythagorean identities, that's cosine squared plus sine squared equals 1. Then tangent squared plus 1 equals secant squared. Then cotangent squared plus 1 equals cosecant squared. Okay, and that's what we're going to use to do a whole bunch of stuff. So you need to try your very best to memorize these because you will use them a lot this unit, and you're going to use them next year if you end up taking calculus. Okay? So if we need to find the exact value of sine of theta, and we're given that cosine of theta is -4 over 7, and it's in the second quadrant because it's greater than pi halves and less than pi. So that's the second quadrant. Well, I'm just going to draw a triangle right there in the second quadrant with the terminal side right there. Theta is always the angle with the x-axis. Cosine is adjacent over hypotenuse. So my adjacent side is -4, and I know that's negative because I went left. The hypotenuse is 7. Hypotenuse is always positive. So I'm going to use Pythagorean theorem to find that missing side. So that's x squared plus -4 squared equals 7 squared. X squared plus 16 equals 49. Subtract that 16 over, you get x squared equals 33. So x equals the square root of 33. And that's that line right there. So sine is opposite over hypotenuse. Well, the opposite side is the square root of 33. The hypotenuse is 7. Okay, not too bad. Let's look at this one. So we're given that the cotangent is 2/5, and it's greater than 180 and less than 270. So that's the third quadrant. Draw that little triangle there. Well, cotangent is adjacent over hypotenuse. So the adjacent side is 2, but that's -2 because it goes left. And then I think I said adjacent over hypotenuse. It's adjacent over opposite. So then the opposite side is -5 because it went down. And that's true because the cotangent is -2 over -5, which would be positive 2/5. Okay, now I'm going to use Pythagorean theorem to solve for the hypotenuse. -2 squared plus -5 squared equals x squared. That's 4 plus 25 equals x squared. 29 equals x squared. So x equals the square root of 29. Cool? And then cosine is adjacent over hypotenuse. So that's, shoot, I did that wrong. Ignore that. That would have been sine. So cosine is adjacent, which is -2, over the hypotenuse, which is the square root of 29. Well, I need to get that square root out of the denominator, so multiply by the square root of 29 over the square root of 29. And that equals -2 square roots of 29 over 29. Okay? Not too bad. You just have to draw that triangle, figure out, ignore that cosine stuff. Bye, that's wrong. Whoops. Okay, so you just have to draw the triangle and then find your missing side, and then you can go find the ratio. Okay, so let's get into simplifying expression. This is when we're going to use all of our fundamental identities. So to simplify an expression means to rewrite it as a numerical expression or in terms of a single trig function, if possible. And we're going to use the identities to do this. So my biggest thing here is we want to always try and get it in terms of sine and cosine if possible. Okay, so sine of theta, that's already sine of theta, but secant of theta is the same thing as 1 over cosine. So I'm just going to rewrite this as sine of theta times 1 over cosine of theta. We can put the sine of theta over 1 and multiply, so that's sine of theta over cosine of theta, which sine of theta over cosine of theta equals tangent of theta. So there's our answer. We got that down to one single trig function. Cool? Let's do this one. So we have 2 secant squared of theta minus tangent squared of theta. Well, let's use, we know that secant squared of theta equals tangent squared of theta plus 1. So let's use that. So that's going to be 2, and then we're going to just put the tangent squared of theta plus 1 in for secant squared. And then that's going to be minus tangent squared of theta. Those tangents cancel. I'm left with 2 times 1, which is 2. Cool? Let's do this one. So sine of theta times cosine of theta over tangent of theta. Well, let's first try and get it in terms of sine and cosine. So I'm going to replace tangent of theta with sine theta over cosine of theta. And let's just rewrite that. So that's going to be sine of theta cosine of theta divided by sine of theta over cosine of theta. If you divide by a fraction, you can flip that fraction and multiply. Put that over 1. Those sine of thetas cancel. You're left with cosine of theta times cosine of theta, which is cosine squared of theta. And we got that down to a single trig function, so we're good. Okay. Again, let's get this in terms of sine and cosine. Okay, secant of theta equals 1 over cosine. So that's going to be 1 over cosine of theta times secant squared, or sine squared of theta, over 1 plus 1 over cosine of theta. I'm going to put that over 1. So the top is sine of theta, sine squared of theta over cosine of theta, over 1 plus 1 over cosine of theta. Let's make that so I have a common denominator so that we can make that one fraction in the bottom. So we're just going to multiply the 1 by cosine of theta over cosine of theta. And that ends up being sine squared of theta over cosine of theta divided by cosine of theta plus 1 over cosine of theta. We are just going to rewrite that. So sine squared of theta divided by cosine of theta. And that's divided by cosine of theta plus 1 divided by cosine. You can flip that fraction and multiply. Then those cosine of thetas cancel. And I'm left with sine squared of theta over cosine of theta plus 1. I'm going to use that to get this in terms of all cosine because we're still not down to a single trig function. So I'm just going to rearrange that. So if I have cosine squared of theta plus sine squared of theta equals 1, I can subtract the cosine squared of theta over, and I get sine squared of theta equals 1 minus cosine squared of theta. I'm just going to replace that. And then that is the difference of squares. Because 1's a perfect square, cosine squared of theta is a perfect square. So that's the same thing as 1 plus cosine of theta, and then 1 minus cosine of theta. Well, the 1 plus cosine of thetas cancel, and you're just left with 1 minus cosine of theta. Okay. The biggest thing on these, I know that seems like so much, but the biggest thing on these is you just have to get started and you just have to keep treading. Okay, you just have to keep going through, you have to keep trying stuff until you can get down to one single trig function. Okay, always try and put it in terms of sine and cosine, and then just keep working until you get to an end result. You cannot give up on these because some of them will be really long, some will be really short. Okay, now let's get into proving identities. So proving identities is basically the same as simplifying them, except we're just simplifying them to get them so that both sides equal the same. And you always want to pick the more complicated side to work with. So on this one, we're going to work with the left side of the equation because sine of theta, there's not much we can do with that. Okay, so let's first put this in terms of sine and cosine. So tangent of theta is sine of theta over cosine of theta. And secant of theta is 1 over cosine of theta. Rewrite that so that's sine over cosine divided by 1 over cosine. You can flip that second fraction and multiply. So that's sine over cosine times cosine over 1. Those cosines cancel and you're just left with sine of theta. which is what we wanted it to equal, so we're done. Cool? Let's do this one. This one, I'm going to work with the right side of the equation because that's more complicated than just the cosecant of theta. Start by putting it in terms of sine and cosine. So cotangent is cosine over sine. Secant is 1 over cosine. So that's cosine over sine divided by 1 over cosine plus sine. Rewrite that, flip that fraction, and multiply. So you get cosine squared of theta over sine plus sine of theta. Well, I'm going to make that so we have the same denominator so that I can add these. So that's going to be cosine squared of theta over sine of theta plus sine squared of theta over sine of theta, which is cosine squared of theta plus sine of theta over sine of theta. Well, cosine squared plus sine squared equals 1, so that's 1 over sine, which 1 over sine is cosecant. So we proved that, and we're done. Okay, again, you just have to pick a point, and you have to go. You just have to start working. Always get it in terms of sine and cosine. First, that's the easiest way to do these. Okay, this one, again, let's work on the right side because it's more complicated. Let's get it in terms of sine and cosine. So cosecant is 1 over sine. Cosine stays as that. Tangent is sine over cosine, and cotangent is cosine over sine. We multiply on the top, you get cosine over sine. Then we need to get a common denominator on the bottom. So I'm going to multiply that first fraction by sine over sine, and I'm going to multiply the second fraction by cosine over cosine. So you get cosine of theta over sine of theta divided by sine squared over sine cosine plus cosine squared over sine cosine. So we can just make that into one fraction. And then cosine squared plus sine squared, or sine squared plus cosine squared is 1. So I'm just going to replace that with a 1. And then I'm just going to rewrite this. So that's cosine over sine divided by 1 over sine cosine. Flip that fraction and multiply. Those signs cancel, and I'm left with cosine times cosine, which is cosine squared of theta. Okay? That's all we're going to do for the notes. We'll do more in class. So make sure you take the quiz. I will see you guys tomorrow.